Systems of equations. Systems of equations require the number of equations has to equal the number of variables. So we're going to look at today a basic system of two. That means two equations, two variables. Now there are three methods of solving systems of equations. The first method is graphing. We graph the linear lines. I'm not going to talk about that. All right. Second is called substitution. Third, elimination. Now, I have seen textbooks also call it this, also known as the addition method. It's these two methods I'm going to quickly talk about. When we talk about substitution, we take one equation and substitute it into the other equation. All right? So here's an example. Here's my system of equations. I have two equations, this one and this one. And what I'm going to do is I'm going to substitute this equation into this equation. But more specifically, wherever I see y, I substitute into the other equation what y equals. In this case, y equals x minus 1. So wherever I see the y here, I plug this whole chunk in. So this becomes, there's my y, so here comes the other part. At this point, I have a basic linear equation where I do my distribution. Remember, it's negative 3 times x and negative 3 times negative 1. Negative times a negative is a positive. So I did my distribution. Do I have a combined like terms? I sure do. 2 minus 3 gives me a negative x, or negative 1x. Do I have a combined variables? Nope. Only one variable. Do I have an add and subtract constant? I sure do. Here and here. This is a plus 3, so to undo it, I minus 3. Negative 1 minus 3 gives me a negative 4. Last step is divide. And what do I divide by? Remember, that's actually a negative 1. So I divide both sides by negative 1. I get x equals 4. Now, I am not done because each equation represents a line. So if you have two lines on a graph, that means they cross at a point, and each point has a coordinate. It has an x value and a y value. So once I get the x value, I need to go back up, pick one of the equations, and plug the x in. So I'm picking this one. Where I see x, I plug in 4. So 4 minus 1 is 3. Now this is not the right answer because remember I said this is a coordinate or a point on a graph. And points on graphs come in a parentheses, an x value, then a y value. This is my answer. Now there is a check to this, and the check is that you take the equation you didn't use. I use this one to solve. I didn't use this one. And I plug in my x and my y value and see if I get a true statement. Well, 2 times 4 is 8. Negative 3 times 3 gives me negative 9. It should come up to be negative 1. 8 minus 9 is negative 1. I have a true statement, thus it's checked. The check step is not typically a required step. However, if you made a math error figuring your points, whether it is here or here, check step will catch it. This method is called substitution. because I substitute one part of one equation in for part of another. The other method is called the elimination method. And the reason why it's called that is because we are going to eliminate one variable. So in this case, I'm going to go and use this equation. There's my system, my two equations. I look at this and I'm going to use the elimination method. That means the first thing I got to choose is one of those variables I'm going to eliminate. And is it going to be X or Y? Well, guess what? It doesn't matter. Personally, I'm going to go after the Y. So I look at this. That means I need to make both Y's the same value. So think like common denominators per se. What number do both 9 and 3 multiply up to? Well, the answer is 9. So that means I need to multiply either both or one equation by something. Well, to do this, I only need to multiply the 1, and I'm going to multiply by 3. However, to be able to eliminate or cancel it, I need different signs. One needs to be positive, one needs to be negative. So right now they're both negative, so that doesn't mean I'm going to multiply by 3, but by negative 3. I'm not touching the top one, so I'm going to go ahead and bring it over. The bottom one, I'm going to distribute the negative 3 all the way through. So negative 3 times x gives me a negative 3x. Negative 3 times negative 3 gives me a positive 9y. And negative 3 times negative 6 gives me a positive 18. I am now going to add down. This is the reason why some books refer to this as the addition method. When I add the two equations together, the y's disappear. They're eliminated. But 4 plus negative 3 gives me a 1. Negative 9 plus 18 gives me a 9. So my first part is x equals 9. Like the previous method, I'm going to pick one of the equations, plug the answer I just got back in, and solve for the other variable. So I'm going to use the top one. Why not? I plug the 9 in for the x. So now 4 times 9 is 36. I subtract 36 off because I'm now solving for y. Negative 9 minus 36 gives me a negative 45. I divide both sides by negative 9. So I get y equals 5. So my answer, remember again, this is a point on the graph, needs to be written as a coordinate point. X value first, y value second. To check this, again, we can have a check step. I take the equation I didn't use and I plug these values in. So I plug in my 9 and I plug in my y. Let's see if I get a true statement. Well, negative 3 times 5 gives me negative 15. 9 minus 15 gives me negative 6. I have a true statement, so I have a correct answer. This was a real quick video on systems. If you need more practice, there is a worksheet attached. Good luck with the Accuplacer.